All right, a mediator in a multiple regression model. So you run the multiple regression first. Okay, you look at your R squared, whether it's significant, your beta weights, et cetera, et cetera. But if you suspect that one of your predictor variables is acting as a mediator between another predictor variable and a DV, this is how that works. Okay, this is what we're going to be doing in this quickie video. So there's the model, right? The IV is actually controlling the mediator, and it's the mediator that's controlling the DV. So A, B, and C are what we call path coefficients between the variables, and the variables have to be continuous or ratio or scale. And these guys, path coefficients, you can think of as correlations, okay? So that's just how strongly are these related? So the direct effect between the IV and the DV is, you would just run a simple correlation between there. It is supposed to be significant, okay? And the indirect effect between the IV and the DV, that means that the IV has to be somehow controlling or correlating with the mediator, and the mediator in turn is controlling or correlating with the DV. So this all has to be proved mathematically before you can call something a mediator. Okay. Again, you need significant relationships between the IV and the mediator and the DV. And the indirect effect, it's kind of hard to explain. So I pulled one of these definitions off of Wikipedia and tried to reword it a little bit so it makes more sense. But the indirect effect measures the extent of the DV is affected by the mediator once you hold the IV in control, or you fix it, you hold it, mathematically speaking, that is. So after holding the IV constant, what is the relationship between the mediator and the DV? So is that strong enough if you fix this? And if it is, then that's proof that this fixed IV is in fact controlling the mediator. And that's the test. Will go ahead and look at the strength between the mediator and the DV and between the IV and the mediator. And it puts them all in this giant calculating machine that it's called the Sobel mediator test, and it will tell us if the mediator is in fact a true mediator. Okay, so strong relation between the IV and the mediator, strong relation between the mediator and the DV, and the direct effect between the IV and the DV has to be a significant relationship. That all has to be true before you can start looking for a mediator, okay? I am going to try to explain what is really going on here. So even though your IV and DV are strongly correlated, that's fine and dandy. There's nothing wrong with that. But it's not a true picture of what's really going on, okay? What's really going on is the IV is kind of controlling the mediator, and it's the mediator that's controlling the DV. So that's what's really going on. It's a little bit difficult to put your mind around, but again, we'll let the math do the heavy lifting. So we're going to go ahead and do an example. And I have a data sheet that we're going to go ahead and use for the guided homework as well. So we have our IV is complaints, our suspected mediator is helpfulness, and our DV is customer satisfaction. So let me go ahead and pull up the data sheet. Ta-da! All right, are these significant? Are all these path coefficients, or think of them as correlations, are they significant? So let's go ahead and just run a quick correlation, analyze, correlate, bivariate. We're going to stick all three of them in there. Ooh, I already did it. Yeah, aren't I great? Click OK. And so complaints to employees, significant, positive. Complaints to customer satisfaction, significant. Employees to satisfaction, again, we got significance. So we're good to go. Yep, they're all significant. So let's keep going. So this is where you get your data to plug into your Sobel calculator. Okay, we're going to run a simple regression. Remember, a simple regression is one IV and one DV. So the first one we're going to run is this one. We're going to say the IV is the IV, and we're going to pretend the mediator is the DV, just to get those numbers. So let's do that right now. Back to the data sheet. You're going to go to analyze. You're going to go to regression. You're going to go to linear. So the IV is the IV. That's the complaints. And our employee helpfulness is what we consider the DV because we're just testing it, okay? Let's just see what we need over here. We always need that. Get over there, get over there, get over there. I'm not going to check the assumptions here. That'll be in a different video. So keeping going. Click OK. And we simply want these numbers right here. So our unstandardized B weight for complaints is 0.176, and its standard error is 0.031. So these are the values we're going to use in the Sobel calculator. So let's do the second simple regression. This time we're going to treat the mediator as the IV and the DV as the DV. So it's going to look like this. Let's go ahead and run that and see what it looks like. Analyze, regression, linear. So we're gonna move these around a little bit. We want employee out, complaints out. So the DV is going to be customer satisfaction, and the IV is the suspected mediator. And those should be the same because I didn't reset it. So click OK. And again, we only want the unstandardized B weights. There they are, 0.785, 0.143. Hold on. All right, 0.785, 0.143. Okay. So we're almost done, believe it or not. So now we have the different path coefficients from our little love triangle there. We're going to go ahead and plug them in to our Sobel calculator. The link is on our website somewhere. So here's the calculator. I'm going to pause it while I type in the data there. All right, there's the path coefficient between the IV and the mediator and the standard error. And there's the path coefficient and the standard error for the mediator to the DV. So you cross your fingers, you're going to click calculate. This p-value is what you're going to look at, so that we're using the Sobel test. So the Sobel test, the p-value is itty bitty bitty. It's 700 thousandths, 800 thousandths. So it's obviously less than 0.05. Therefore, we have just proved that helpfulness is in fact a mediator between complaints and customer satisfaction. That was so much fun, I'm going to say it again. Because the p-value of the Sobel calculator was less than 0.05, that proves mathematically that the employee helpfulness is indeed a mediator between complaints and customer satisfaction. That's it. Hope you enjoyed it. Math Guy Zero, out.